Hello and welcome to my class. I'm Grolin Annesley from ThinkMO Education. I'm currently a Cisco Technological lecturer. If you like my video, welcome to my study group. Or contact my teaching assistant. WhatsApp account is +6 583444290. Today's topic is the basic concept of network. An OSI 7-layer basic model. Before starting class, let me first introduce to you. Actually, what we learn in the CCNA stage is relatively simple. We are more focused on an understanding of the basic framework of the network and some simple commands. For example, assign an address, run a simple protocol, knock some simple VLANs, including ACL and NAT, which we will cover in the last lesson. Then let's practice typing a configuration. More than that, I hope everyone can lay a good foundation. Okay. We are now officially starting classes. Today we are more focused on knowledge of network infrastructure. That is the basic concept of the network. And a brief introduction to the OSI 7-layer model. First, I hope you all know. We now learn the main purpose. In fact, it revolves around 1. Communication of overall data, or network communication. For example, let's take a relatively simple question. For example, this is my device on the left, the teacher's computer. I connected to the server of the teaching platform. I'm giving a lecture. You may be listening to my lecture on your phone or computer. Is that actually understandable now? Here are the students. I'm equivalent to right now from my device. Produced a data. I use the teaching platform to generate a data. So in the future this data, with the help of the network we have already built, pass it on to the students. So what we call data communication actually means I have generated a data on one of my devices. The future relies on our overall network. The process of sending to everyone's side. We call this process network communication. In fact, this process, it's very similar to sending a courier. I will send you a courier. Then after I pack the courier with intermediate logistics, the process of reaching the hands of the students, we call it data communication. But for us, everyone will find, overall it sounds simple. I send a data and you receive it. But what we have to learn is, why do you receive? Why does my device generate a data you can receive? That's like a courier. Why after packing, hand over to our logistics center, it can reach its destination? This will tell us a framework problem of the overall network. So let's start with the basics today. Explain our current online world. We call it a world where everything is connected. How is it made up? Let's take a look together. Give a relatively simple example. We will draw later. If I now draw a picture like this sideways, then draw a device on my behalf. This device is called a switch. Today we will not talk about its communication principle. Just follow my rhythm. For example, let's take a small company as an example. So as a company, these squares I'm drawing now is a PC. We have a lot of office staff. In the future, many employees will use such a computer. Let's set up a simple network for it first. In the future, we will pass the network cable one by one. Connect it to the intermediate switch. This forms a minimal network. Just this network. We say it can only communicate within the network. We can't go online. But we also formed a network. That is to say, everyone will find out in the future. Between my computer. If you want to communicate with each other, we have to connect. That is, we have to insert a network cable in the middle. In other words, I want to communicate between my devices. I want to make sure this device is near me. Or we want to connect. So we will go through some lines in the future. We pass some relays in the middle. That is based on such a relay device plus a link. Realize the interconnection between our end devices. That's basically after we've made the connection. Internet connection between PC and PC. This is our small network structure. A network range like the one I'm drawing now. It is a lot. That is, for each of our companies. In fact, we can all set up such a small local area network. That is to say, there are many companies, like the ones we mentioned earlier. Every company. In fact, it is the same networking process. Then I will copy it a few. This is equivalent to many companies around the world. They are all like this. Then we have to think about a question now. According to a question we just mentioned. Between each company, I both buy some switches like this. Such a device. Then buy some network cables. We connect the terminals together. Between each company PC and PC. They are able to communicate. But now the problem. Each of our companies. If they all form a separate network. Between my company and the company. Will there be a need for mutual visits? Think about this. For example. Let me give a simple example. Suppose the company on the far right. Company C. Then it's not a PC. Suppose this is a server of Company C. Then for them, how a company makes money is to open their web services to the outside world. That is, I don't care whether it's advertising or anything else. In short, for the user, I just give them access. That is between our company. There is a need for mutual visits. That's the problem now. As we just said, between businesses. If we were really just building alone, a small local area network, such a network range, that actually my business. Companies cannot communicate with each other. That's the network of each of our companies. In fact, the future needs to be connected. For example, as a server of C company, there are people from all over the world who want to visit Company C. But its companies are not everywhere. How to connect between different companies? You can't directly pull a network cable or an optical fiber. I am connecting from my device to Company C's device. Certainly not. So how do we connect now? We now seem to. I can't handle it myself. Then there is a new business. This new business is the operator's business. When will everyone learn IE in the future? Our many courses, or a lot of technology, will be aimed at the operator's environment to deploy the network. So everyone must know. In the face of the time when we are now surfing the internet, we use the carrier's internet. The internet is run by the nation, or deployed and built by operators all over the world. We call it ISP. Our country's largest electronic information operator. All have the right to build the overall network. Purchase equipment, laying line construction equipment. Everything they have. Such infrastructure. So say. We are now actually. All operators' networks are used. What is the operator doing? They actually do the same job as a courier company. I will give you a simple example. You want to send a courier from area A. Or you want to send something from area A to area B. Then you have two options. One is that you fly, holding this thing. Sit all the way to area B. Hand over to the opponent. The other one is that you can hand it over to the logistics company. Let them help you forward. Data communication is the same. It can be used to pull a bare fiber. Pull it from area A to area B. But then, first, you don't have infrastructure rights. You do not have the right to connect the device privately. Second, the cost is too high. You can't afford it. So actually, the carrier does the job of the courier company. But in our network industry, sounds a bit more high-end. The operator is for everyone in the country. It all offers the same business. But the business is the same. Fees are different. Still distinguish between low-level and higher-level users. How is the connection between the operator and the operator? We will also connect like this. Not through a VPN. But if you say VPN, it also fits in my picture. Because we are local intranets, right? If the same company, intranet and intranet, want to communicate with each other, we generally use a VPN. But that's not what we're talking about today. What we're talking about today. For example, I go to visit C company from ThinkMO. There is no VPN between us. Let's take a simple example. For example, these devices on the far left. This is a company in region A. The ones on the right are assumed to be from the B region. Then we do now. When deploying and building equipment, our company is in region A. I will connect to one of our company's export devices. That is our company. In the future, there will be a device called a router. We generally draw a circle to represent a router. Then I would connect to the company's outlet. And this router for this egress. In the future, it will be connected to the network of the operator. Make a connection with the operator's equipment. Then in the future we can follow. The operator's network is connected. That includes the same for region B. I will also connect to a device exported by my company now. It's the same for me. I drew it all for you. Our connection. Connected to each of our cities. In the access equipment provided by the operator. That's actually equivalent to passing this way. We are connected. For a device like this we speak. The operator is also the equipment here. I won't draw anymore. Let's just understand. There are many cities in our country. So the future is for every city. Will come and go by the operator's business. Open it up as a whole. The operator is responsible for each of our cities. Interconnection between every city and every city. Then they're the ones who pay for the equipment we use. Now the operators have already built overall network architecture. Everyone needs to know this first. That's how we get online now. How do I get access from area A? For example, a server in region B, carrier-based network, is equivalent to. Actually now we have achieved. We have interconnected devices across the country. So everyone can understand. Between cities. Via the lines laid by future operators. We're already connected. For example, now I am in area A. If I am currently in region A, one of my devices wants to access this C company. We need money to do business. I just need to spend money now to handle the corresponding business of the operator. For example, how many megabytes of fixed bandwidth do I have? How much will I pay for the annual fee? Assign me an address in the future. I will leave this device after I surf the internet. Then you can go online. It is equivalent to after we access the operator. According to our different needs. Can handle different paid services corresponding to operators. Locally my device is connected to the carrier. The operators in various places are connected by themselves. Then we can rely on the original operator. Achieve our nationwide connected information devices. and tell everyone, whichever operator, their overall business can be connected the future. No matter which operator you are dealing with. The official website. All servers that provide access services to the outside world. You can all access. This is what we call one reason why the online world is connected to each other. It's here. This is what we're talking about as a whole. Interconnection between cities. In fact, everyone can imagine. We have a division of regions. Generally speaking, we put every company or every organization, unit organization. It can even be said that it can be as small as every family. A network range we are currently in. I circled in red. This is a local area network. It is a very small network range. We know that as network engineers. Our first step in the future may be to enter a business. To start from the most basic network workers. You will often hear a term called enterprise network or campus network. That actually, they can be said to be a concept in the local area network. That, for example, I put an organizational structure in a local area network, run in the overall campus network. We call it a campus network. Used in a corporate network. It's called an enterprise network. But actually we run the strategy, some commands to configure. And the overall planning thinking is not too bad. They are all within a local area network. For network architectures like ours. Configuration to go. So first we need to understand the concept. That is in our city. Our overall network architecture. We call it a metropolitan area network. One of our classmates mentioned VPNs before. VPNs in their oldest. There is another means to replace it. If you connect two businesses within a city, we really have bare fiber access. That is, we directly use the dedicated line of the real line. Let's go to Las Vegas and build a line. Then what we said really goes through bare fiber. Connect two different intranets. In fact, it is all within the metropolitan area network. Some operations. Because it is expensive. The network between our cities is called a metropolitan area network. But now the word mentioned a little less. Because for us, in fact, in the current large environment, we only divide the intranet. That is our local area network. And wide area network. So what is a wide area network? Suppose now that I draw this picture. Covers many cities. Overall, it covers the whole country. For our country's operators. In the future, we will also communicate with operators in other countries. Operators in other countries will communicate with operators in other countries. Until the whole world. After all operators in various countries are connected. In fact, it can be achieved worldwide. Everything is connected. In fact, this architecture diagram we are drawing now, although simple, regardless of the architecture you will see later, how huge. From our macro perspective, it's all like this. But what we said does impose some limitations. But we logically, if no restrictions are made, our network communication is really like this. No matter how complex the network architecture you will face in the future. Actually, from a higher point of view. Actually, this is the picture. For example, we will be in the local area network in the future. You will learn a lot of techniques. There will also be many under the WAN. We will also have a lot of intranet and wide area network access. That includes for operators. Data center. There will be some different technical points to explain the subject we are talking about today. In fact, it's about a theme. It is a theme of the interconnection of all things. Sometimes we often hear a sentence, Internet of everything. I always feel a little bit mystical. But please pay attention. What we say now. Access to everything on the Internet. All data. It's really up to us one by one. Connected by real physical lines. Equipment and equipment. Really real device. Through each other. Real physical wiring. Then our world. It is really such a network structure. It's a very large online world. This is also for us as network workers. Why we can have high salaries in the future. There could be a reason for a more challenging job. Because our network is really very large. That's why we only have internet access on our computers. Access your business from any device in the world. As long as it provides access to the outside world. With your permission. Because everyone's network. We are all connected by carriers. There is no doubt about this. Each country. Now all our access needs are implemented by the operator. If no operator, no access to the operator's business, then we can only be in one LAN. That for now. Some of our business models for various companies and business type. It's all illegal. Because now we are the age of the Internet as a whole. All business is now done online. This is an interconnected state. Mentioned above. It's all about the overall architecture of the network before the class. What you need to know. The structure we are talking about today is very large. But throughout the NA stage, we will only learn a small piece of knowledge on a small scale. That is, in the overall stage of our CCNA. What we talked about today. Between operators and operators. Within the operator. Between the future local area network and our operators. All technology are not involved in the NA stage. All the techniques we have learned. They only exist in such a small local area network. First of all, everyone should be clear. What do we use the technology we have learned at this stage? When everyone learns NP and IE in the future, knowledge will gradually expand to the outside world. That for us. In fact, in a small area. That is, in the future, you will be in a corporate network. Do some of the most basic configurations. In the enterprise network. This is what we do in the NA phase. We can divide the network as a whole into 3 areas. The first is called a local area network. Local area network. We are now relatively close. We will have a unified management model in the future. To provide services for a unified business. Equivalent to this is by our engineers. A network built in-house. Then whether you are a small business or medium-sized business, large enterprise, no matter what your network architecture looks like, you are a local area network. Then secondly, for our metropolitan area network, between cities, our geographic range is relatively farther. But we say the concept of now, gradually eliminated. What about us now? Why we don't go anymore? What about the word metropolitan area network? Because whether it is a metropolitan area network or what we call the wide area network now, we're actually referring to both the operator's business. Because in fact the metropolitan area network is also based on the operator's equipment. Network interconnection. So it's also the operator's service. The WAN is also a service of the operator. So we can only distinguish now a network range that we have built ourselves and the range of operators. So we only have one LAN and the concept of wide area network. Therefore, the metropolitan area network is relatively old. That is still our WAN has not developed to at such a level now. Once the metropolitan area network is still brilliant. Now we will no longer mention this concept. Above are some of our communication concepts. Knowledge of wireless in Cisco. I should talk about it in IE. There will be no wireless part in our NA. Just do a simple extracurricular understanding. We've covered communication concepts and communication architecture. Then we'll get started. Learning of communication principles. That is, how does it work? Why can? What parameters are there as a support? This is what we will learn later. We've been repeating a word today. Operator. Other than the operator. We also mentioned a lot of network devices today. Such as routers. Such as switch. For example, these PCs in our terminal. First, let's briefly talk about history. From the early days of our entire network development. In fact, when the computer was first born. Not for network communication. It just acts as a real computer. Used for high-speed mathematical operations. Physical operation. And that it was actually prepared for military and scientific research. It has many formulas. What we humans are best at is creating and using tools. We call the possible formula developed. The parameters also came out. And how to calculate also calculated. Computers have also developed. Later, you can calculate the launch path of the missile, etc. We can make computers later as a real computing device and can store a large amount of data. Later, as we slowly develop, the team of scientists hopes to put the whole computer synchronize data. Because if the core data is destroyed, that's a very serious price. So the Ministry of Defense came up with the demand. They want to synchronize the overall data. It is hoped that the synchronization of information can be achieved by some means. Earliest network. We are through satellite-based synchronization. But for now it won't work. That cost too much. So the network is actually developing slowly. Did not start with computers. Network now. Then you can go online. Not like this. You are looking at the needs of each era. But in the middle of our process. I won't go into too much detail with you. As the internet began to spread slowly, we'll find that there is a problem. Each country has its own manufacturer of equipment. Such as IBM. That for early. A manufacturer like this. Actually, it was at some point monopolized our overall communications business. We're going to do a meltdown backup. So, that is, the whole network is in the process of communication. Everyone will find. Because there are different network communication standards between different manufacturers. So will lead to, if you go to buy a manufacturer's equipment, you can just buy all the equipment. Only buy from this manufacturer. Because only this one manufacturer's equipment only support this set of communication standards developed by their own manufacturers. Like my number. For example, what format should our information be compiled into? How will each layer of data be transmitted in the future? How is the data of each stage identified in the future? Every manufacturer is different. So if at that time, you want to communicate over the network, you have all the equipment, all communication standards, all terminals, buy from the same manufacturer. Otherwise, you will not be able to communicate. Because of the signals passed from device to device. Don't know each other. Interoperability is not possible. So if in such an environment, every manufacturer, both individually manufacture their own standard cases, different manufacturers, it is impossible to communicate between devices. Because the data can't understand each other. But you will find The whole world can't just buy equipment from one manufacturer. That's an exaggeration. So, our network actually developed in the beginning. Very severely restricted. So let me tell you this. We'll refer to one of our reference models today. Every time I tell you about this model directly, it may seem abstract to everyone. Every time you start learning, you must start with the model. Every company I just talked to you about. Every manufacturer. Per manufacturer. They have their own standards. It corresponds to the model we are going to talk about today. Because this model is to define the standard of our overall network communication. So everyone learns the model. The first thing to know is that the core problem it solves is when the world follows a set of models for network communication, then in fact it constrains the various manufacturers, their ability to create their own communication standards. Then it is mandatory for us all over the world. All manufacturers follow the same set of standards to produce and manufacture equipment. So in the future we will be building a network. And the network will be traceable when it develops. There is a saying called, "The real enemy of mankind is disorder." When an industry wants to grow rapidly, or to a certain extent, then it must have a set, complete communication standard. Then in our entire curriculum, the first thing we learned was the OSI 7-layer model. To us, at the stage of model making, in fact, business growth is very slow. It's just that we're Messier. Business will grow faster. Which is now for our entire network. We used to have a lot of standards. You can simply take a look. Our once popular IPX standard. First, let me introduce the relationship between them. When we explain the course, we will explain a set of reference models. A 7-layer reference model called OSI, also known as Open Systems Interconnection. Then we explain it according to it because it will be more detailed for the network level division. But what we actually use now, all communications equipment in the world, the only set of industry standards followed, a model called TCP/IP. Everyone should know this. That is to say, we will explain the course according to OSI. But actually we now, using the TCP/IP model. Well, these have been eliminated as originally. These are some old network models. But some of what we said was once. Why are there so many? In the early days of our overall network development, there is no set of standards in the network industry. Therefore, a set of standards is urgently needed. Standards proposed by brands, manufacturers, or organizational units. Everyone doesn't care about this. As long as there is now a set of standards available worldwide, all equipment is standardized. As a consumer, one of our thoughts. So around 1977, ARPANET proposes a set of standards called the TCP/IP standard. Just want all network devices. In the end, communication is carried out according to this standard. But it was not adopted. Because for each manufacturer, in the midst of development, suddenly come up with a set of standards. Then it is equivalent to all their equipment cannot be used. Manufacturers' equipment have their own standards. So it won't follow other standards. But you will find the whole trend of our world as a whole must be in order. Standardization is an irreducible step. So, ARPANET as the originator of the network model, they continue to push their own TCP/IP model all the time. Until the second half of the same year, the OSI model was also proposed. ISO's International Organization for Standardization. This ISO is actually the formulation of our entire industry. Industry standard. That OSI is just one of the standards they propose. This organization is specialized in setting standards. It just so happens that they also set the standards for the networking industry. Nothing more. These two are the network models we are going to learn. So what is a network model? That is to say, our current network. What set of standards will be used for communication in the future? For example, I am now going to generate an application data with a lecture program. How should each layer of this application data be encapsulated? How to transmit the final data in accordance with our network communication specifications? How to achieve communication according to our set of standards? This is the model that exists for communication. The meaning and value of existence. The communication standard we actually use now is TCP/IP. Let me stress again. When we explain, we will start with OSI. So let's make a network model, like our OSI reference model today. Just for first unify a standard for our current overall technology. Next, we will divide the hierarchy. What function should we accomplish in each layer? Make a command. The third convenience is to teach everyone now. If the overall knowledge of the network is framed, smashed together to talk, it will be difficult for you to understand. Then according to our current level of division, I will tell you about each layer individually. Then it will be easier for you to understand. So it is from the teaching direction. Is also relatively simple. But actually OSI is more about helping us provide a means of fault location. In the future, when everyone learns IE, they will go to the experiment. If you haven't worked yet, no real troubleshooting experience, then maybe a little blur on it. Then in the future, you will execute it when you arrive in IE, or will go to the configuration of some experiments. Then you need to quickly locate. For example, there is no internet connection. Where is the network not working? We need to troubleshoot quickly. We generally have two methods. Top down, then bottom up. Generally speaking, if we rule out layer 2 failures, layer 4 failure, generally speaking, we can quickly locate. Now it's a 3-tier fault, because the upper 3 floors we will talk about today. It has nothing to do with our network communication. That is when we troubleshoot. We're not going to see if there's a problem here. Then look up to see if there is any problem. Then look up. Usually not so. We all read above and below. If there is no problem above and below, that's the problem in the middle. Since the division of each layer is very clear, then each layer will have some fixed inspection methods. It will help us to quickly locate network faults in the future. This is the meaning of the existence of the OSI reference model. Then we start to formally talk about this model. The OSI reference model has 7 layers. This is mandatory for everyone to remember. Must meet NA this stage as a whole for 1 month. You have to remember these 7 layers. First, follow us from the bottom first. The physical layer. We call it the first layer. Further up, this is called the second floor and the third floor. Suppose I learned a layer 2 technology. We usually mean I learned a technique of data practice floor. Suppose I learned a 3-layer technique. Actually means I learned a network layer technology. What we are learning refers to the hierarchy in OSI. We just talked about a model called TCP/IP. So although we now using this set of models, but it's in the whole model. For our 7 layers, a merge. It merges our first and second layers into one network interface layer. or data interface layer. Layer 2 refers to the network layer. Layer 3 is the transport layer. And merge the upper 3 layers into one application layer. We call it the big application layer. So although we are using TCP/IP now, but when we call it technology, it's not called according to the second and third layers. We are still in accordance with the second layer. Is the data column drop layer. The third layer is called the network layer. Here are some habits of our spoken language. The future of our overall data communication. According to our overall hierarchy. Hierarchy means that each layer is carried out sequentially. Let's go back to this picture. Let's start to explain layer by layer. I first talk about the most basic physical layer. For the physical layer, it is slightly easier to understand. For example, for the most basic physical layer, the physical layer studies. For example, how is the computer connected to the switch? What is this device in the middle? Or the middle wire is a network wire. We call it twisted pair. Inside is copper core. Then why do I plug in a twisted pair and it can communicate? Think about this. Where did this rule come from? This is the standard defined by our physical layer. If for the future, how does it transmit data? We're going to stipulate now. Such a line. How did it get on our device? As a network device. It has a network port. This network interface on our computer is called a network card. Now this crystal head has to be plugged into the network ports of both of us, so that communication can take place. This network port is an indispensable element in communication. It is also defined by our physical layer. That is to say, there is definitely not a random line in the middle. There are also production standards. When the network cable is produced, we also have the order to say so. These things are specified by our reference model. That's actually done by our TCP/IP. In this reference model, in the network interface layer, physical layer specification. But we are still talking about OSI.